Hello and welcome to this Year 8 lesson on fractions, decimals and percentages with a calculator. Can you please rule off from your previous work, put today's date and the title of fractions, decimals and percentages with a calculator into your book and make sure that they are underlined. Once you have done that, can you have a go at the Do Now task which is displayed, so you can pause the video here and have a go at answering those questions. Okay, let's have a look at the answers to the questions on the left-hand side. So firstly, we're rounding to one significant figure. The important thing to remember here is when we're dealing with numbers bigger than 1, the first significant figure is always the number farthest to the left. So in this instance, this 1 here is our first significant figure. So all I need to do is to look at the number next to it, which is a 5, and because of that, we would round the 1 up to a 2 and change any other digits in the number to a 0. So 15 becomes an answer of 20. If we now look at this second one, we've got 150. First significant figure is 1, rounding that up because the next number is a 5. That becomes 200. In C, very similar, so that one would become 2000. When we get to D, you'll notice that we have 1.5, so the first significant figure again is the 1. The number next to it is the 5/10, so we would round the 1 up to a 2. There would be no need to put 0.0 here because when we're rounding we're trying to lose accuracy and therefore we can just leave that as an answer of a whole number of 2. And then in question E we have 0.15, so the first significant figure here is not the 0 because we're looking for the first non-zero number, so again it's the 1, the number next to it is a 5, we round the 1 up to a 2, so your answer would be 0.2. On to the questions on the right hand side. We just have to follow the rules of BIDMAS and then round our answer to 2 decimal places where appropriate. So in the first question, we have 2 cubed, which is 8, divided by 1, still leaves us with 8. 3 take away 8 is -5, add 5 gives us an answer of 0. In B, we've got 7 cubed, we then add that to 5, which gives us 348, and because we're dividing by 7 and timesing by 7, that just cancels each other out, and so therefore we still have 348. And then in C, 6 subtract 1 is 5, add the 7, we get 12. In D, 7 plus 8 is 15, we've got -4 squared, which is 16, so 15 take away 16 is -1. We times that by 2, following BIDMAS, we get -2. Add 1 takes us back up to -1, and then in the last question 49 is 7 squared, we add that to 6 which is 55 and add the 1 to get 56. So in today's lesson we're going to know how to use your calculator efficiently, we're going to understand how to calculate decimals and percentages of amounts on your calculator and be able to calculate fractions of amounts on a calculator. Pause the video here, have a look at the hook question. This is something that we will come back to later on in today's lesson. But have a look at it, see what you think. Okay, hopefully you've had a good think about that problem and we will revisit that later on in today's lesson to see how we might approach it. So, moving on to your calculator skills, one of the important things that we need to do is know your calculator. So most students have the latest version of the Casio calculator, the FX85 GT. These are available to buy from the finance office upon return to school, or you might be able to order one online if shops are still providing that service. Firstly, we want to identify where the fraction button is. So it's this button here on the left-hand side of your calculator with a white rectangle over an empty rectangle. There is also a percentage button on your calculator. You'll notice it's above the answer button and it is in yellow font, which means you're going to need to press the shift button in order to be able to access that percentage button. And then finally there is this useful button here, which is kind of an S and then some arrows to a D, and this converts your answers between fractions and decimals. So what I'd like you to do now is to have a look at these 2 questions. How do you use the percentage key on your calculator? How do you use the fraction key on your calculator? I'm going to pause the video while you have a think about the answers to those 2 questions. Okay, let's see how that would work then. So firstly, if we had a question like this, calculate 15% of 20. Now using my calculator, this is actually a very straightforward process. What we would first do is type in the number 15 onto my calculator, then press the shift button and then press the percentage button. What you should see is 15% now written on the display of your calculator. Whenever we see the word of in a question, that pretty much means multiply. So what you can now do is type in multiply, and then you can type in 20. And that should, when you press the equals button, give you an answer of 3. But how else could we calculate 15%? Well, another way is to think about percentages as decimals. So we know that 15% could be written as a decimal as 0.15. So alternatively, we could, using our calculator, write 0.15 times by 20. That means exactly the same thing. And again, on your calculator, you should now have an answer of 3. If you haven't yet, try both of those calculations on your calculator. I'll pause the video while you do that. Okay, let's have a look at another problem. Now we're going to calculate 32% of 150 grams. So again, follow the same process. 32, then the shift button, then the percentage button, then multiply 150. And that will give you an answer of 48. Again, we could do this using a decimal multiplier. So rather than using 32%, we could use, that's right, 0.32. So on your calculator, you can type in 0.32 times 150, press the equal sign, and you get an answer of 48. What I'd like you to do now is to have a go at these questions using the percentage button on your calculator, and these questions using the decimal multiplier technique on your calculator. Pause the video while you have a go at those questions. Okay, let's go through the answers very quickly. 30% of 120, you should have had 36. 16% of 200 should be 32. 13% of 50 should be 6.5. 56% of 750 is 420. And then the questions using the decimal multiplier, 60% of 420 is 252. 12% of 200 gives us 24. 35% of 140 gives us 49, and 72% of 800 gives us 576. Here's another question. Calculate 41% of £6.50. So again, we can use our calculator. 41, shift, percentage, times 6.5 equals 2.665. Now, of course, here we're dealing with pounds and pence, and what it may be appropriate for us to do is to round that answer to 2 decimal places. Therefore, in that question, we may want to offer the answer as £2.67. How else could we calculate 41%? Well, we know we can use the decimal multiplier technique as well. So 0.41 multiplied by 6.5 again gives us £2 and 0.665. As we've said, the problem with this answer is that it's not in the correct denomination if we're dealing with a value in pounds and pence. Now, in certain walks of life, when you're dealing with huge numbers of transactions, you do actually break down into partial degrees of pence. But for most calculations that we would do in day-to-day life, we need to deal with sort of whole number values for pounds and pence, and therefore it makes sense for us to round that to 2 decimal places. Can you now pause the video while you have a go at those questions and again select an appropriate degree of rounding for your answer? Okay, the answers are now displayed on the screen, so check those out and hopefully you have had success with each of those different calculations. What I'd like you to do now is to take a look at the question on the screen and again think of the answer to this question and write it down, an explanation of your preferred method and why. Pause the video while you do that. Okay, so as we can see, there are 2 different approaches here. Mo has gone straight from taking 35% and turning it into a decimal and using a decimal multiplier to bring up the answer of 52.5, whereas Teddy seems to be doing his as what we would call a build-up technique by finding 10% and 5% and 30% and bringing the 30 and the 5% together to get his answer. Which do we prefer? Well, probably we would prefer to use Mohs technique because it's quicker and easier, but you would need to be comfortable multiplying 0.35 by 150, which if we have a calculator is really straightforward. If you don't have a calculator, then maybe actually Teddy's technique would be more effective because it allows us to build it up in easier to use blocks. Let's now have a look at a new problem. So using estimation to support your calculations, Rosie is working out 37% of 2,800. She uses the following calculation to estimate the answer, 0.4 times 3,000. Is this a good way to estimate? Why or why not? Pause the video while you have a little think. Okay, well, what did you think? I don't think in this case it's too bad as an estimate to be able to round both of those numbers to one significant figure as Rosie has done. It gives us a rough idea of what the value of the real answer is going to be, although we know that it's not going to be precise. So in this instance we've rounded both the 37%, which has been written as a decimal, up to 0.4, which is effectively 40%, and we've rounded the 2,800 up to 3,000. That would give us an answer of 1,200. Now, because I've rounded both up, I know that's going to be an overestimate to my answer, and when we actually work out the correct answer using our calculator, we get the answer of 1,036. But why do we estimate the answers to calculations? Well, sometimes we need to be able to do calculations in our head, and actually by changing the numbers to more straightforward numbers like 0.4 and 3,000, it enables us to do that more fluently. And that can help us to solve problems quickly, or at least better understand whether something's affordable, or rounding values so that we have a clear understanding, because we don't need necessarily the precision at that point. So what I'd like you to do is to use an appropriate estimation, rounding to one significant figure in order to find the actual answers to the following questions. Pause the video now and then have a go. Okay, so let's have a look at these questions on the right hand side. In the first one in A, we had 22% of 2,100. So an appropriate estimation here might have been to say, I want 20% of 2,000. That would give you an answer of, say, 400. And when we work out the actual answer, we get 462. So it's pretty close. In B, we might have rounded 48% to 50% and done 0.5 times by 2,000, which would give you an answer of 1,000. And again, the answer here is 864, and because we've rounded both answers up, you can understand why. In C, we've got 63% of 5,700. That could be rounded to 0.6 times by 6,000, which would give you 3,600, and the correct answer there is 3,591. And in D, we would round 2.3% to 0.02 to 2% basically, and do 2% of 80, which is already to the one significant figure, and that would give us 1.6, and the actual answer is 1.84. And then in E, your rounded value should be something like 12 from finding 20% of 60, and the actual answer was 11.285. Okay, we're now going to have a look at calculating fractions of amounts. So if I wanted 2/5 of 75, what we would need to do is to press the fractions button on our calculator, and the numerator put 2, and the denominator put 5, then press the right arrow to enable us to put in a multiplication sign, and then type 75. And that should give you an answer of 30. What other calculations could you perform to find 2/5 of 75? Well, we might know that 2/5 is actually the same as 40%, because that's 4/10, and therefore we could do 40% of 75, or also we might choose to do 0.4 times by 75, and all of those would give us an answer of 30. Can you now pause the video and have a go at these questions here on the right hand side? Okay. Now you've had a go at those, the answers are displayed on your screen, so you can check those against what you've written. And hopefully we've had success there, and we will move forward. So a bit of a challenge now. What I'd like to do is to, using as many different methods as you can, find 27% of 400. Pause the video while you have a go at that. Okay, hopefully you've used some different techniques. You might have used the percentage button by typing in 27% times by 400. You may have also used 0.27 multiplied by 400. You may have even used the fraction button and 27 over 100 multiplied by 400. Did you come up with any others? If you did, then share them with your teacher. It'd be really interesting to hear some of your ideas. Okay, here's another little investigation. So Jack says that 27% of 500 is the same as 54% of 1000. Show that Jack is wrong using a calculator and using a diagram. So over to you. Pause the video and have a go. Okay, hopefully you've come up with some interesting proofs using calculation to that question. What we'd like you to do is to take a picture of those and pop them in the work submission folder so we can have a look at some of the ideas that you've come up with. Now for some true and false questions. 40% of 50 will give the same answer as 0.4 times by 50. Do you think that's true or false? True, well done. Let's have a look at the next one. 1.5 times 36 will calculate 15% of 36. Is that true or false? False, well done. We need 0.15 there as our multiplier. Let's have a look at the next one. 3/8 of 35 is the same as dividing 35 by 3 and then multiplying by 8. Is that true or false? False. 3/8 of 35 is not the same as dividing 35 by 3 and then multiplying by 8 because we've got the numerator and denominator the wrong way round there. A suitable estimate of the calculation 0.67 times 2,499 would be 0.7 times 3,000. Is that true or false? That's false, because while we've got the rounding of the first part correct, the second part should really be rounded to, that's correct, down to 2,000. 3/7 of 142 equals 60.86, correct to 2 decimal places. Is that true or false? You can use your calculator, obviously. Well done, that's true. Okay. Last thing for today, I'd like us to look at these two questions. Pause the video and have a go. Okay, if we have a look at this first question, Amazon are selling Harry Potter DVDs at 40% off. The original price is £14. John takes out his pocket calculator and inputs 0.4 times 14, and the answer is £5.60. John thinks this is a great discount. Has John correctly calculated the sale price? Well, no, John's actually calculated the percentage discount. And so what John should have done was then taken that £5.60 away from the original price of 14 in order to get the price he pays. Let's have a look at the second question. There are 60 marbles in a bag. Joe says he has 2/5 and William says he has 2/6. Evie says that leaves 26 for her. Is she correct? Well, what we firstly need to do here is find 2/5 of 60 by using your calculator, and that should give you 24. We can find 2/6 of 60 using your calculator, which gives us an answer of 20. Add those two together, that gives us 44. And then what we can see is actually that only leaves us 16 and not 26. What you should now do is go to your class worksheets and have a go at the tasks relating to today's lesson. Thank you very much for your time, and I hope you have a good rest of the day.